Hey, this is Tommy, and today we're learning 1.2 of mass spectrometry. So, mass spectrometry is used to find the atomic mass of an atom. So, in order to find that very specific, precise number that they use mass spectrometry, which catalogs the mass of different isotopes. So, I have the mass spectrometry, or a fictitious one, of an element. And the graph is graphing relative abundance versus mass. Now mass you can see is m over v, m over charge, and relative abundance you can see is relative abundance or percent abundance. Now, in order to get the mass, or the atomic mass of an atom, you have to look at all of these bars and get a weighted average of the mass. And the way we do that is by getting the relative abundance of each isotope. For this one, it is about 0.15. For this one, it is about 0.4. 53 is about 0.2, and 54 is about 0.25. So now, in order to get our average, we have to take this, do 0.15 times 50 plus 0.4 times 51 plus 0.2 times 53 plus 0.25 times 54. And that comes out to be an atomic mass, or an average atomic mass, of 52 AMU. Now, what we can do is solve the table and see which element has 52 AMU. And if we look on it, we can see that chromium fits the bill. Chromium is 52.0 AMU. In this graph, most of our atomic mass is concentrated in the isotope of an atomic mass unit of 31, as well as an isotope with an atomic mass unit of 32. So right off the bat, we can kind of look at this and say that, oh, our isotope is going to be in the range of 31, 32. And based off of these being over here, we can kind of already estimate that it's going to be 32 range. But in order to really find out, we go over, find our relative abundance of each isotope, which for the isotope with 35 AMU is 0.1, 0.1 for 34, 0.3 for 32, and 0.5 for 31. So now we could do our calculation to get the average atomic mass, which is 0.5 times 31 plus 0.3 times 32 plus 0.1 times 34 plus 0.1 times 35. And all of this will give us an atomic mass of 32. Now we can consult the periodic table to find out our element. And it turns out to be sulfur, which is 16. And it has an atomic mass of 32.06. And this is going to be the closest we are to any element. With the surrounding element being phosphorus, which is at 30.97, and chlorine, which is at 35.45. So we can pretty safely assume that this is going to be sulfur. But now we can get to the question which I put up in the top right corner. How many neutrons are in the isotope with an AMU of 34? So atomic mass is the combination of protons and neutrons. So if we subtract out the protons, we can get the amount of neutrons that are in that isotope. So if we remember that atomic number is the amount of protons, we can subtract out 16 from 34 and get our answer of 18 neutrons.